Good day everyone, we are from Group A SFT1013 Waves and Optics. Our group name Physics Fancy. Our group consists of Noor Izaty, Zulaika, Thushidrasri Armugam, Rhivekka Dewi and Mithra Subramaniam.
Experiment 1. Simple pendulum. Objectives of this experiment is to study the motion of simple pendulum, to study simple harmonic motion, to learn the definitions of period, frequency and amplitude, to learn the relationship between the period, frequency, amplitude and length of a simple pendulum, and also to determine the acceleration due to gravity using the theory, result and analysis of this experiment.
Check the stopwatch and pause it. Pause the simulation. Set the angle to 5 and start the simulation by clicking the pause button again. Measure the period for 50 oscillation. Pause the experiment and record the period shown from stopwatch. Repeat the same steps for length of pendulum 0.20 meter until 1.00 meter. Check the stopwatch box option. Set the length pendulum to 0.6 meter. Pause the experiment and stopwatch and set the angle to 5 degrees. Select pause button and begin measure the period for 50 oscillation. Pause the experiment after 50 oscillations and record the period in the data table.
For results part A table 1, the period increases as the length of pendulum increases. In the table 2, the frequency decreases as the length of string increases. For the graph part A, period versus length of pendulum, while for graph 2, period square versus length of pendulum, the period taken to oscillate depends on the length of pendulum, which resulting in the linear relationship. For part B, displacement of pendulum 0.60 meter, while amplitude is act as manipulated variable and period as responding variable. This graph shows that the relationship between amplitude and period is not proportional as in non-linear but as increases as the value increases. Discussion from the result, the value of acceleration due to gravity based on the experiment result is 9.69 ms2. The percentage difference obtained is 1.12%, which means that the difference between value obtained and the accepted value is small. The theoretical value for this is 2.01 second obtained from the equation t equals to 2 pi square root L over G and the longest length equal to 1.0 meter. Then the theoretical value compared with the experimental value, which is 2.02 second, and the percentage difference of t value of experiment result and theoretical result calculated is 0.5%. It signifies a small difference between the theoretical value and the experimental result. Simple pendulum experiment is familiar to use since it is related to simple harmonic motion, which is related to the topic in SFT1013.
In a nutshell, we were able to understand the motion of a simple pendulum. A simple motion is motion in a straight line, circular or circular. The longer the length of the string, the farther the pendulum falls, therefore a longer period of the pendulum to swing. Then, the greater the amplitude, the farther the pendulum falls, then longer the period. Lastly, we were able to find the acceleration due to gravity using theory, which is 9.69 ms2. From this, we can say that we were able to achieve all the objectives of this experiment.
Experiment 2. Reflection of light by a plane mirror. Objective of this experiment is to compare the angle of incidence of a light beam with its angle of reflection. Second, to develop skills in measuring accurately and in the use of protractor. Procedure. First, we place a white sheet of a paper on the table, which we draw a line on it. Then, we place the mirror in its position where it's supported by placing an object behind it. start, we place the protector on the line drawn on the white sheet of a paper, and we shine the laser towards the mirror once the light in the room was switched off. Fourth, we made a mark where the laser reflected off the mirror, and another mark was made at the exiting beam. Then we turned off the laser and removed the mirror. We connected the points and draw the path followed by the light in the reflection process. We measured and recorded the angle of incident and the angle of reflection using a protector. The incident and the reflected ray drawn and will look like a large V. We repeated the steps with pointing the laser at different angles. We measured and recorded the angle of incident and the angle of reflection with different angles. Result. Table 1 shows the angle of incident and the angle of reflection obtained in this experiment. The incident angle at 20 degree, the reflection angle we obtain also 20 degree. The incident angle at 30 degree, the reflection angle we obtained was 28 degree. Incident angle at 40 degree, the reflection angle we obtained was 41 degree. The incident angle at 50 degree, the reflection angle we obtained was 48 degree. Incident angle at 60 degree, the reflection angle we obtained also 60 degree. The incident angle at 70 degree, the reflection angle we obtained was 68 degree. The incident angle at 80 degree, the reflection angle we obtained was 79 degree. Incident angle at 90 degree, the reflection angle we obtained was 90 degree also. Discussion. This experiment is related to the subject where in chapter 4 we learned about the law of reflection, which the angle of reflection is equal to the angle of incident. From the first law we know that angle of incident is equal to the angle of reflection and not approximately equal. The result we got from this experiment is approximately equal to the angle of reflection and the angle of incident. This is because maybe there are high chances of errors that may come during taking the measurements, which is known as human error. It also depends on narrowness of the light beam. The narrower the light beam, more accurate will be the result is. When greater the angle of incident ray, the greater the angle of reflection ray. During this experiment, when the angle of incident was increased to 90 degree, the laser light did not touch the mirror and thus the laser light produced a straight line which result in 90 degree at the both sides.
Conclusion. In conclusion, the law of reflection refers to the reflection of light on the smooth conducting surface. The angle of reflection is almost equal to the angle of incidence. Both the angles are measured with respect to the normal to the mirror.